Yo, what's up? Welcome back. Today we're working on this little stream start screen that we have up and running here. So its thing right now is like it like looks like we're like typing into a terminal saying like, hey, here's what we're doing today, and here's when we're gonna start, and here's how long it's gonna be until we actually start talking. He's showing negative times right now because stream has started. And we should probably eventually fix that so it clamps itself so that it says like switches scenes or something. But anyways, the idea is we kind of wanted to try making this like some sort of like 3D scene where maybe we show that like same text, but we like display it on like a monitor or something, and like with like a little bit of like, you know, artistic flair in 3D or whatever. It'd be kind of fun to like show like the CRT with some CRT effects and like show the desk and whatever, you know. Maybe this will look a little better, maybe not, but it's a good excuse to like explore 3D rendering and like that side of things. So what we've done so far is we've like started working with OpenGL, trying to write like a 3D renderer that could render this scene for us. It's a very simple scene, right? There's like 3 things in it with like a couple lights. But hopefully by implementing all this ourselves, we'll get like an intuition about how all this stuff works. And if we want to start like adding on stuff, hopefully we'll have like a better idea of what's important, what's not. And then if we ever want to flip back into like doing this in a game engine or something, we'll have like a better intuition on how stuff works under the hood. So what I want to work on today is like lighting and texturing. So right now we have like these 2 monkeys that we've imported from or exported from Blender, and you can see like they're kind of there, and we can see like some sort of like 3D movement. They're like rotating, and we're looking at them from like below. So there's like some sort of like 3D going on, but they're just like totally flat. They're all one color, and that's because we haven't done like any attempt to implement either lighting or texturing. And so there's kind of like two aspects of this, right? One is sorry, this is the texture that we made last stream. So on the right is like us, we've drawn on like little eyes and like some lipstick for her. And on the left here is like the image that actually comes out of that. So what happens is normally you have like each face is like, or each vertex, I guess. No, probably each face. Each face is like mapped to a specific spot on this image, and so like you can kind of see that like if we were to draw here, we'd probably get her ears. We draw here, we'd probably get her face, here her eyeballs, whatever. And yeah, the plan is to try to like import this into our thing. And so if we just did that, we would kind of it would still look odd, but it would look a lot better because we would essentially see exactly how do I turn off can I turn off like lighting in our like overview here? Maybe not. But like you can kind of see like when I like rotate the camera and stuff, I see like a different this thing changes color. And if I like take the light in the world and move it around, maybe in this view, we see like different effects on like different faces. So there's like kind of like 2 aspects to this. One is like we want to implement like this sort of light thing, and one is that we want to implement like loading a picture onto our little guy. Yeah, so that's what we're working on. Okay, so I guess let's start with trying to like load the texture. So our application has like no idea how to import an image. Right now we've kind of written a object file parser. So like in Blender, we take this mesh and we export him. We say like export as obj file. And in here, what that essentially does is it exports this like basically list of vertexes. And along with those list of vertexes, we also get like normals that are associated with them. So like which way should the light bounce when it hits this face? Essentially, like which way, like how is my surface tilted? Or I guess how is my point in space tilted? And then we also get texture coordinates. So like where in that 2D image is this specific face located? And so we like can import parts of this. We haven't really covered all of it. We're importing just the 3D points and the faces. And then we have to import texture coordinates as well. But we also have to import the image that we want to display. And we have no importer for that right now. So I think I don't want to go through the hassle of learning how to parse a like an image right now. Like I feel like opening up a PNG is going to be more work than I'm willing to put into it right now. So let's just pull in like this like image library for Rust. Oops, image docs rs, not docs. I don't know what that was. And this is just like a high level API for reading images. In fact, we can probably even go a little lower. Maybe we can import like something for PNGs only, which I think is written by the same people. Let's see, or at least like wrapped by this image library. So this image library, he depends on one of these PNG. Yeah, so we can probably just work with only PNGs for now, and that's fine. And yeah, these are the same guys. And that'll lower our dependency tree a little bit. So let's pull that in. So we can go to PNG. We want version 0.1710. And let's just do that. So we'll say PNG is equal to 0.17.10. Cargo check, which should make sure that we build. Cargo build, I guess. And was that all it took? That was quick. Maybe we have to use it for it to get actually built. So for now, let's just start by trying to load the image and seeing what happens. So in our main, we could do something like, before we do anything, we'll return. I guess it's return we succeeded, just so that the compiler is happy. And then we can say like pung and load. I guess we need to like actually look up the API of this guy. So if we do cargo doc open, is that going to give me local documentation for this library? Hopefully. Open in the wrong window, 1 sec. Let me find the correct browser window. This one. Yeah. Here we go. And in here, we want to like look for pung. Is this? Do I already have the image crate? Did I forget that I already pulled it in at some point? Oh, we did. And I guess we probably don't need it. Like, I think nobody's using it. We just forgot to delete it after some of our, like, sample code. Just out of curiosity, let's check out our dependency tree. So we have, like, some, like, macros for generating errors, OpenGL stuff, text stuff, time stuff, PNG stuff. Okay, that's not too bad. That's not too bad. They're using, like, compression libraries, CRC libraries, bit flags. Yeah, that's not too bad. Not too bad at all. Okay, so let's regenerate our docs. And it opened in the wrong frickin' window again. The wrong window. So pung. Look at this pung. Pung crate. And presumably one of the many things you can do is read. Mostly high-level interface. Okay. Provides a high-level interface that iterates over lines or whole images. So here is a frame, and this decodes a frame into buffer. I wonder if this is a little too low level for us. Oh, here's an example. They open a file, they run the decoder, they get info, they get a frame, and they get the bytes of the image. And how do I know, like, don't I need to know the format of the image in some way? Like, how do I know if it's like RGB, like what pixel depth, etc.? I guess that'll be like from our info, probably. Okay, so they're saying, oh, get a decoder. Read info, which gives us a reader. And this guy has an info on him. Oh, and he has all the stuff that we care about. Yeah, okay, that's fine. I think we don't need anything more high level than this. That seems reasonable. Yeah, that seems reasonable. Seems reasonable. So let's say pung decoder new. And we're going to have to do this from a reader. So we're going to say let f is equal to file open, what is our thing called? We have a Sue's texture.pung. Let's open that guy. And we'll just unwrap him for now because this is debug code. We probably need to import files, so we'll use std.fs file like this. Nice. We're probably gonna want to wrap him in like a buffered reader because that's faster, even though it doesn't really matter. And this like it's probably just good to do it by out of habit. So say let f is equal to buff reader new f, which means that we need like io buff reader or something. Fs buff reader. Buff reader rust. Buff reader. Oops, we forgot to update this guy. Yeah, so this is in stdio. Cool. So then we create a buff reader out of him, and then we decode the ping from him. Do I unwrap this? I don't know. Is my indexer running? Feels like something should be yelling at me. Yeah, because this is clearly not working. So, I think it was read info unwrap. Yeah, nice. I'm gonna restart my Vim because it feels like my indexer isn't running. Yeah, there we go. This is more like it. Yell at me, compiler. Thank you. So we'll say let reader pung reader is equal to this, and let's print out like info about this PNG. So I think it's pung reader.info or something. Cargo run, and let's just kind of see what we get. So we see that we have a 1024 by 1024 texture with 8-bit color depth with alpha in there. So this should be enough. So if we like pull the data, stick it in a byte, an array of bytes that is the right size, and then upload that to the GPU, that should be pretty straightforward and easy. So let's do that. We can say, we can go back to their little demo, wherever that was. Here. So here they get the output buffer size. Nice. Okay. So we can say let buff is equal to, or we'll say image data is equal to vec of zeros with the output buffer size. Something that's kind of like fucked about like Rust here is that really we shouldn't have to initialize this thing with zeros. We should be able to just not care about the data in there and then try to overwrite it with the reader. But because of some of their like interfaces, I'm pretty sure that it's invalid to do that. So we have to do it this way. We have to say, here is a zero initialized buffer. And then we say, read the next frame, and a ping might contain multiple frames, sure. And what does next frame return? Why is it returning an info? Output info. Oh, so this gives us like information about the specific frame, which is nice. Bit depth is fixed to some of those. Usize is, or sorry, line size is the pitch. So you might have like, you might have an image where your data is like in this side, but you have like some like extra padding in here just to make sure that like lines are aligned in some way. Sometimes it's more effective. Okay, but that's pretty straightforward. There's nothing really to worry about here. So we'll say let image info is equal to image data or pung reader dot next frame. And what do they say to do? I wasn't paying attention. Next frame. And we pass in the buff as a mutable image data. Okay. Cargo run. He doesn't like that the ping reader is not mutable. Cargo run. Okay, that's fine. And then we can just try to upload this to the GPU. So we'll say function load texture. We'll take in GL. We'll take in like our OpenGL context. So this is going to be glow context, I think. And we're going to take in the metadata for our PNG. So we'll say load texture from pung. And so this guy's going to take in some info, which is output info. And he's also going to take in the bucket of bytes. So here, it's going to be like this. And he's going to return a texture that we can render to the screen. Okay, so all of this guy is just going to jump in here. And then we're going to say unimplemented. And again, like, why isn't he yelling at me? LSP restart. Come on, man. Something is like I've got no auto-completion. I've got no inline links. Is it because my thing's, like, so wrong that it's just failing? Use glow native texture. Unimplemented was spelt wrong. Unimplemented. Okay, so now I compile again, and I'm just gonna restart again, because I don't know why the fuck that happens sometimes, where, like, the indexer just stops telling me what I want it to tell me. Okay. So now we have to figure out how to, like, stick this on texture. So we have a utility function, gl util create texture with default parameters. Okay, so we'll do that. And the reason we do that is because we struggled on our first day where we tried to upload a texture to the GPU, and if we didn't set these like kind of like bitmap levels, which are like, how are you going to interpolate between things when your pixels are different sizes, right? If they're really small, what are you going to do? If they're really big, what are you going to do? If you don't set these, we ended up like just getting black. So we set some defaults there that say, basically disable bitmap, like disable multi-level textures or whatever. And so we'll say let text is equal to this, and we'll return the texture at the end. And now all I have to do is like stick the data in here. So somewhere we must have done this already. Bind texture. Yeah, here we go. So this isn't actually, binding the texture isn't what we want. We want the part where we upload the image. Yeah. So we bind the texture, and then depending on the parameters, these inputs might change. So let's look up this like GL text image 2D thing. What's he doing? So here are like, basically we're saying, here's our data, and here's a bunch of information about it, and I want you to think about that, essentially. So target is going to be something related to 2D texture, so that makes sense, texture 2D. The level is like the level of detail, like bitmap levels, whatever. We're not doing any of that like scaling, so we're just going to say it's always 0. Internal format is going to depend on what our PNG data was. So we're going to say let, oh wait, sorry. Internal format is it might be, one of these is how are we going to store it, and one of them is how did they store it. So we can probably say that internal format is what we want to store as, and we can just always say RGB. Maybe we should do RGBA. Maybe, which is one of the valid options, or sorry, internal format RGBA. Yeah, that's valid. We can always say RGBA, and if it's not RGBA, it'll like coerce itself into it. That's fine. The width is going to be image info dot what were the things in here? So I think we need to unwrap this, and we have width, but we have to be careful here because width and line size are kind of different here, and we probably want to store line size here, and then clamp in the texture if line size and width do not match each other. We do a little trying to unwrap because it was a U size, and if our image was like really fucking big, like unreasonably large, it wouldn't fit into an I32, but it will always, so it's fine. We can just unwrap it. We want to do its height here, so image info dot height. Try into unwrap for now. And border, this value must be 0, so we'll leave it as 0. That's like a weird thing to put in here, but maybe this is like an extension API or something. And here's where it gets interesting. So now we need to like say let image format is equal to image. We match the image info dot what does he have again? He's going to have output info. So the color type and the bit depth. These are the two things that are going to determine how we try to pass it to OpenGL. So we'll say let color type is equal to image info.color type. I guess we don't have to do that. We can just do this. We can say match the image info color type as well as the image info.bit depth. And between the two of these, we should be able to determine what we want to put here. Oh no. The color type is one and the bit depth is another. Ah, okay. So we'll say let color format is from here. And then down here we'll say color format. And now we just have to figure out what this guy is. This is a color type, which has these values. And let's pull off the equals. So we'll say anything after equals, we'll place an arrow that does nothing. Oopsies. And then we need to prefix all these with color type. Ping color type is reasonable here. Okay. And what are we going to do? Grayscale, we're going to say is just GL red. Right? It's one channel. So even though it's not gray, we'll say it is. RGB, we're going to say that goes to GL RGB seems reasonable. Indexed, we'll just say that these are unsupported right now. So we'll say panic indexed colors unsupported. That gets a little complicated. I think that we'd probably need to like texture and stuff, which we don't want to handle. Grayscale alpha. I don't really want to handle that either, so we'll just also panic here and say grayscale alpha unsupported. But RGBA is pretty reasonable. So we can do that. That's glow RGBA. All right. So now we just need the bit depth. And it looks like this is always going to be... how do I see this? Bit depth. 1, 2, 4, 8, 16. So it looks like these are always going to be integers, right? These aren't going to be floating point values. And I don't know if we can support 1, 2, or 4. Right? So specifies the data type of the pixel data. They support byte, unsigned byte, byte, unsigned short, short, int. I wonder what, oh, half float, float, unsigned byte 332, unsigned, oh, okay. Maybe unsigned short 444. That looks like it might be it, I guess. They might not support packing in threes, so we'll just have to be careful about which ones we support for now and just hope that it's 8. Maybe we'll just only support 8 for now, and if it comes up, then we'll deal with it later. So, or we can support 8 and 16, actually, because 16 is easy as well. 16 would be unsigned short. So we can say bit depth is equal to match image info color bit depth. And we'll go again and get the data, the thing here, paste it, replace anything after an equals with equals arrow, nothing. Okay, clear the highlight, and prefix it these pung bit depth. Nice. So 1, 2, and 4, we're just gonna say are unsupported. This. And so here we're gonna say panic unsupported bit depth. And we can maybe even shove the bit depth in here. Like this, and probably this needs to be debug formatted. And 8, we'll say we are glow unsigned byte. And for 16, we'll say glow unsigned short. Easy. And then we just huck the bit depth in here. Bing, bang, boom. And shove the buffer in here, which is the image data. Bing, bang, boom. Okay. I bet that's right. Might not be, but it might be. And do we have a way to like render a texture to the screen right now? We probably lost that code at some point because it was like debug code at the beginning. So what we can do though is we can use this. We can like import a plane with UV textures, or we can just like make a plane. Let's do that. So here we'll make a mesh, and we have already support in our mesh for all of the things we need. We have vertex positions, faces that like reference vertex positions, texture coordinates which reference. Well, we don't actually use these texture coords anywhere. We just kind of like started parsing them last time. So we could just like bang out a mesh that's a plane and then try rendering that. Which seems kind of reasonable. That seems reasonable. So, and this gives us like an opportunity to kind of like sort out our texture coordinate system. But it would be nice to be able to like independently verify that our texture is loaded correctly without doing all that. So let's quickly, maybe we just bang out a renderer for texture on screen space coordinates. Do I want to do that? No, I don't. We'll just kind of skip the yeah, we'll just skip an intermediate step and try to go straight to it. And when it doesn't work, which inevitably won't, we will fix it. Okay, so what we did here yesterday was we parsed out a bunch of texture coordinates that are supposedly equivalent to vertex coordinates. Sorry, not like they should match 1-to-1. They could, but in reality, they might match 2-to-1. Specifically, let's see if we can find like seam here. So somewhere, sorry, like where are these guys? Oh, here. Okay, we got, aha. Okay. So imagine these two faces, right? One of them is over here, right? And one of them is over here. So this specific vertex actually is going to be part of is going to have two normal, or two UV coordinates. Like these two that are in between, because it's duplicated, if that makes sense. Right, we have the same vertex here twice. And I was trying to think about like, well, how do you deal with that? Because the way we render right now is we use this call, we hook up some buffers in OpenGL, one of which is like verts. And you can imagine like each one of these guys as being like, essentially like just a bunch of floats, right? So you'll have like 1, 2, 4, 3.3, whatever. This is just like a list of floats back to back. And this is called like the buffer object, vertex buffer. And then we have like this like array object. They call them array obj. And this essentially says like, hey, my shader, he's expecting 3 floats. How do I, like, where should I put them? Where should I get them from? Let me double check. What's in a vertex GL? Let's look for the call. Let's look for the call in our mesh renderer somewhere. Cube renderer, that's what we called it, even though we're not rendering cubes. So somewhere we have our like array object that says attrib pointer. So he says, here's my location, and here's like the width and my type. So he basically says like, hey, when you give me, you're gonna give me a pointer to somewhere in here, and how do I interpret that data? So I'll say like, oh, they're gonna be floats, and there's gonna be like 3 of them. Because like, you have 3 floats to make like a 3D vertex, right? And then we have like one more piece that is the like element buffer. And he basically says like, hey, look at this guy, then look at this guy. How do I say this? Yeah, he's gonna have like basically each of these guys is gonna be like an index into this buffer. So he's gonna say like, draw this one, then this one, then this one, then this one. And so you can kind of like have a list of vertexes, and when you construct faces out of them, oh, sorry, that's not quite right. Sorry, brain farting. So he's gonna say point to here, right? And that's going to use this array object that says like, hey, there's 3 floats in there, and that's going to group all 3 of these vertexes together. And then the second guy is going to say like, okay, now I'm going to point here, and that's going to group the next 3. And this guy might say, okay, now go back to the first one, whatever. But this guy's drawing like, he's kind of like saying, I have a definition of what one element is, and that's going to be some amount of grouping of data, and I want to draw some elements in this order. And all of that is like important to say, because that this like structure really like impacts how we're going to lay out our data. Specifically, if we want our vertex shader to pull in UV coordinates, i.e. like where on that picture of Suzanne are we going to like pull image data from, we need our UV coordinates to be associated with the same element. So our array object here, we would then say, oh, hey, there's also 2 UV coordinates. And now all of a sudden, if you have the same vertex position, the same vertex, but 2 different UV coordinates, that has to be like structured as its own element, because you can't like mix and match like pieces of an input to a vertex shader, I guess. Like you have to kind of like group them, say this is one set of inputs, and I'm going to draw that one set of inputs. All of that to say, in this case where we have vertices that have 2 UV coordinates to them, these actually have to be shown to OpenGL as 2 different sets of vertices. Even though there are like only 1, 2, 3, 4, 5, 6 vertices in these, like across these 2 quads, we still need to say, like, we need to present them as 8, because there are 8 individual sets of UV and position, if that makes sense. So that means that if we want to store our data when we load it from our object, if we want to store it in a way that is like friendly to upload to the GPU, what we actually want isn't, we don't want these like texture coordinates and vertices split like this. Because our faces we're essentially saying that the faces map directly to this like element buffer concept, right? The faces are saying like, hey, I'm going to look at vertex 1, 2, 3, and 4. And that's exactly what this guy's doing, right? He's saying like, I want to look at element 1, 2, 3, and 4. And so what we should do is we can make like this like structure that's like vert and UV. And he's going to, maybe we'll say repr C, so that we have some like, we have some control over the memory layout of this guy, which is going to be important when we try to upload him to the GPU. And here we're going to say that we're going to have an individual vertex, so just one set of 4 points. 3 points, you might think like 3D, why would we have 4 points? There's like kind of like a divisor point, which is like useful in a lot of ways, like mathematically, but don't worry about it. We'll just say 4 here, and 2 texture coordinates, or we'll call it UV. Yeah, okay. And so then what we do is, instead of storing vertices here, we store, we can store this guy as, I guess, vert and UV, which is actually going to make our parsing much more complex. Because, let's see if we can find it. In our object, each face is defined as a set of indexes into both the UV and vertex buffers. So like here you see like 61, 61. That means the 50, the third thing in here is the normal buffer. We're gonna get to that later. But you can imagine like here you have 22, 22, which says like vertex index 22 and UV index 22. But you might have some that don't match up, like 85, 92. And so like, do we see an 85 slash that isn't slash 92? Let's see, 85 slash. Nope, they're all slash 92, but there are going to be some that don't match up. And so essentially what we have to do when we're parsing is first we're going to have to parse all of our vertex and UV coordinates. And then we're probably going to like take pairs of these guys, so pairs of indexes into the original buffers, and we'll just kind of store those as an index into a new buffer, I think. So I think what we're gonna want to do is essentially build up some structure that's like, first we parse all of the vertex and texture coordinates individually, right? But then we're gonna make a new one that's like, let mut vert and UV is a new vector. And what we can do is we can like build up a map of a pair of coordinates, or a pair of indexes, sorry, to the new vector. So we could say like we could say let mapping is equal to hash map new, and this is going to be a hash map of like vert index and texture index to like merged index, essentially, if that makes sense. All of these guys are going to be usizes, but using type names here makes it a little bit clearer. So you can say type vert index is equal to usize, text index is usize, and merged index is usize. Sorry, we have to use stood collections hash map like this. And if that makes sense, what's going to happen is we're going to iterate over our faces. And for each face, we are going to we're going to see if we've already seen this pair of vertex and UV. And if we haven't, we will insert it into this new vector. So we'll say like, if we've seen this, take the index of vert and UV for that pair. If we haven't seen it, create a new vert UV pair and push into vert and UV. And that's it. Then at the very end, we can discard these other vertices. So these other vectors. Okay. Which also actually might mean that hold on, let me think for a second. I was going to say that we might have to parse in order to do that. Like we might not be able to parse faces until we get to finish parsing UV coordinates and texture coordinates or whatever, or UV and vertex coordinates, but I think it's fine. So all we want to do now is we just want to say that like after we parse all these faces, we're going to have to do a conversion at the end. Which I think is fine. So we're going to say that we're going to have a function that takes in obj data to mesh, we'll call it. And the obj data will take in vertices, which is going to be a bunch of floats. I guess it'll be a slice of four element arrays. The UVs are going to be a slice of 2 element arrays. And the faces is going to be a slice of, I guess, two U sizes, right? The vertex one and the UV one. Which seems reasonable. I guess storing this as a tuple instead of like something with a name is like kind of confusing. So we can actually create like a struct vert and UV indexes. And we'll say vert is a U size and UV is a U size. And then this guy can have faces, vert, and UV index. Cool. And so we'll say let mute ret is equal to vec new. And this guy is going to return a vector of vert and UV. Yeah, ret. Which means that up here, after we've extracted all of these guys, we're going to say, I guess he's not only going to return this, he's going to return this and a new set of indexes into this guy for faces. So then we'll also say struct map, let's see, how do I want to call this? I guess this will just return the mesh. That seems reasonable. And so we'll call this obj data to mesh, and we pass in the vertices, the faces, and the text chords, and the faces. Nice. Okay, sure. And we'll say this guy's unimplemented for a second. And now our parse face thing is going to have to put out something just different. So before he gave out just the vertex data. Just the vertex data. And now we're gonna have to give out a vert and UV index. I think that's what we want. And they're triangles. So I guess we probably got a type wrong here, where this guy is going to take in 3 of these at a time for every one per triangle. That looks more reasonable. Noise. Which means that this parse function that used to only parse the first thing should now also parse the second thing. So we already are splitting by slashes. We get the vertex ID. And so this guy needs to be a vert and UV index with zeros. So vert 0, UV 0. That's going to be his initial state. Which I think compiles. Not really sure. Yeah, and so ret I vertex coordinate is going to be this. What doesn't it like now? He doesn't like that it's not copyable. Which it probably shouldn't be. But yeah, why does he want a copy there? Okay, so let's derive debug on this guy so he can be printed. That's important. Cube renderer has some problems because he's expecting the old format. Which we can find if my computer doesn't crash. Nice. Yeah, so here, I guess we'll just, uh-oh. Am I crashed? Oh no, oh god. Come back to me, baby. There we go. I guess we'll just comment this out for now. That's the easy fix, and we'll put a little fix me, re-enable. We'll re-enable it later. What else is it complaining about? So here in obj parser, this vert and UV thing and this mapping, these aren't actually used, so we'll delete all this, and I guess this will eventually go into this like obj data mesh, but we'll comment it out for now because the type resolution isn't working. And we're back at 110, so it doesn't like. it doesn't like that he expected a U size, found a U32. So I guess that's fine. We can just convert these to U32s instead of U sizes. That's more defined anyways, because when we upload to the GPU, we don't want to have to like think about whether or not we're on 64 or 32-bit, which is great. And now the last part is that it cannot fill this array with these guys without them being copyable, which is annoying. So I guess we'll just copy paste it 3 times. And that should fix it. Close. And we're at main 338. He tries to write the texture coordinates, and we can't do that anymore because they don't exist in the same way. Easy peasy, bing bang boom. Okay. So once we have split on slash, we are then going to have to do this same thing, but instead of getting it for the vertex ID, we're going to say for the texture ID. Noise. And so this is going to be ret I UV is equal to this. And I think that's it. Invalid face, we'll call this face UV just so that we have like a slightly different error so that we can like trace back a little easier. Yeah. And here we'll say second element doesn't exist. Sure. We can crash there. Fuck it. Okay. Why don't you want vert and UV index to be copyable? It seems like 6 bytes is a lot. It's really the only reason. But you're probably right. That's fine. That fits in 1 register. So maybe that's fine. I just initially was thinking that it was more data than like a simple copy implies, right? If you were to like make a giant array copyable, then like you might accidentally start expending a lot of time on mem copies that you didn't mean to. But I guess on a 64-bit system, 6 bytes is like nothing. So I could make it copyable. You're right. You're right. Okay. So now we are going to start doing this like conversion. So we'll say all of these guys are going to have in prefixes on them so that we can just use we can like differentiate easily between input and output. Here we have our mapping and our output. We'll call this output, vert, and UV. And so I guess we just iterate over the faces. For face in faces. We'll also have to make like an output faces. Thinking. Yeah. And this is also going to be a vec new. And so what we should do here is we should say face dot like what right, okay, so for vert in face we look at its vert and UV index, which we can actually just use as the input to our map here. And we will just say if mapping dot contains, does it have like a at get? What are like the APIs on this guy? I can't remember the hash map APIs. Hash map rust. Oh, I guess we want to use that entry API. That seems reasonable. So we'll say mapping dot end dot. Am I high? Like this is supposed to have like an entry field on it, but my autocomplete's not getting it. But we'll try this anyways. Oh, probably because this isn't hashable. I bet. But we'll try this anyway. So we'll say mapping dot entry vert or insert with, I think is the API here. And we can just like say in vertices output vert and uv dot push, and this is going to be a vert and uv. Vert is going to be in vertices at vert dot vert. Yeah. And the UV is going to be in UVs at vert dot UV. And so now we have an index, and we can return output vert and UV length -1, the index of the last thing that we just shoved in there. And then our mapping will have like a reference to this essentially, which is exactly what we want. Yeah, so this guy needs to be hashable. And maybe like clone and copy or something. Not sure what he's bitching about. Method cannot be called due to unsatisfied trait bounds. Oh, because they need EQ and partial EQ. There we go. And does he need these as well? Clone and copy? Due to the type of argument passed. Oh, so I need to dereference this guy. And this guy needs to be mutable. Oh, this guy needs a type. So, right. So after we get this, we're going to insert into our output faces. Entry something, but we don't want to do that. We're going to say let output face is equal to 0 usize 3 of them, right? Because we need to make a face, we need to make a triangle. Then our, I guess here we're going to say this is an enumerated thing. And then we can say output face I is equal to entry or something. And so that means this guy needs to be mutable. Mapping needs to be mutable. And then output faces push output face. Bing, bang, boom. And then after all of that, we should be able to return a mesh that has vertices, output vert and UV, and faces, output faces. Yeah? Is that all we need? He doesn't like the thing here because he expects U sizes here. So we can say entry as U size. Oh no, he wants U32, sorry. So this should be 0 U32, which means that merged index should also be U32. And this should be try into unwrap. Nice. Nice. Now this guy cannot be moved out of vert, so we need to clone him. I guess this is why we have clone and copy here, which should be fine. Fine. All right. And I actually haven't really thought about if this is right. I just kind of like kept typing until the compiler stopped yelling at me, and it would be kind of cool if that just worked. That would be cool. Okay, so we need to pass in those like arbitrary arguments, and what here we are printing out our mesh, which is pretty cool. And we have our first one is this and this, and it'd be cool to like compare maybe with our actual object file. So let's look at this. Here we have faces 0, 1, 2. And can we maybe check on our cube object? Our first face, let's get way back here, is 47, 47, 3, 3, 1. So our face 0 should correspond with vertex 47, UV 47. And then 3, 3, and 45, 45. So maybe we look at this and we say 46 down from the first one. And let's see if that lines up. 0.65705, 0.001737, 0.100955. That's wonderful. And if we look at where are our UV ones, these are normals. Texture. We go 46 down, and we see 890955, 590063. Mwah! Okay. So at the very least, our first vertex looks pretty good. Looks pretty good. I'm like medium confident that worked. So it'd be kind of interesting to just try texturing now. So when we go back to our cube renderer, or our object renderer that's incorrectly titled cube renderer, before we were trying to say that we have an input that is 4 element floats, chunks of 4 floats back to back. And now we actually have a UV coordinate as well. So if we look at our 3D vertex shader, we have like a second input that'll be an input in UV. And we will want to just pass on that UV to our fragment shader, which is going to like color in the face that we just drew. So here we can say UV is equal to InUV. I think that's all we have to do here. And then in our fragment shader, we're going to take in, instead of a color, we're going to take in a UV. We're going to have a uniform sampler to D texture. And we're going to have to sample that texture. So we're going to say outColor is texture from texture with our UV coordinates. And I think that's it. I think that our fragment shader is actually like somehow simpler now, because all he has to do is sample this guy. So what does that mean for our inputs now? Our inputs, they have to account for the size of these, the fact that our UVs are now packed with our, how do I say this? They are now packed with our vertexes. So here we can say const stride is equal to stud mem size of, instead of F32, it's going to be whatever this guy is called. So if we go back to our obj parser, we have our vert and UV. And so it's going to be the size of vert and UV. And we should actually probably assume that this guy is, we should like assert that he is the size that we expect. So we can say assert that EQ stride is equal to 20, or 5 times stud mem size of F32 for a little bit more readability. So we can say stride as usize like this. And the reason that we want to do this is because like the packing here is very, very important, and we want to make sure that we got it right. So here we can pull in whatever that thing was called, vert and UV. And yeah, it's probably fine. And so I think if we do this and we just don't set our UVs, I think we should still see monkeys rendered, but they should be rendered wrong. So we have a problem at line 83. And, oh, this should be 6. Sorry, because it's 4 and 2. So that was good assertion. And we don't see any monkeys anymore, so that's a problem. That's a problem, it's a problem, it's a problem. And that's because we never uploaded the vertices. So here, this is mesh dot vertices. Yeah, that's fine. And here, What doesn't he like? What doesn't he like? Oh, because we don't, this now can just be anything. Yeah, sure. We upload a slice of anything, and we just get back a pointer slice as a U8. Sure, that seems reasonable. There, okay, so we still see our two monkeys there, which is a really good sign. That means that the like packing of vertexes and UVs is being interpreted correctly by the GPU, but we just haven't told it where the image is yet. Okay, so now an object is gonna have a texture associated with him too. When we right, we're gonna have to upload a PNG with him, I guess. Now we could maybe say that like you could texture these guys individually. Like, how to say this? You might want like I'm trying to think of like who should own the texturing concept, but this is fine. That's fine. We'll just stick it in there for now. And when we upload, I guess for now, this doesn't really make sense, but we'll put a texture here as a native texture. And this guy just gets the texture here. And then when we try to render him, we're just going to say gl bind texture, which is, let's look at somebody else who's done this in our thing before and just copy paste him. Boom. Yep, that looks right. Mesh text. Okay. And then at the end of this, we bind the texture none. Unbind him after we render. And then the last piece is enabling the UV coordinates. So here we'll just say, there are two elements. This is not going to be the vertex location anymore. This is going to be the texture location or UV location. We're going to upload our two floats to the UV location, and we're going to offset these by 4. Maybe 4 times 4, 16. Or 4 float offset. Which means that we need to extract the UV location. So here, this is in UV. And in main, when we upload mesh, we just want to upload the texture as well. So somewhere we had load texture from ping. We can just do that now. So we pass in our jail context. And, oh, this actually doesn't take in info and buff. This creates those internally. So we just take in path as a path. Yeah, that seems reasonable. And so now we pass in Sue's texture.hung, and then let text is equal to this, and we upload the texture here, or associate the texture with him. Great. We're close. Cube renderer needs to store the location of the UV attribute, which goes here and here. And we need to import the native texture type from Glow. Ideally, I'd like to have all of the GL stuff like kind of like hidden away a little bit so that like it doesn't leak externally in case we ever want to switch out OpenGL implementations, but it doesn't really matter. Do we compile? We're close. We're just missing stood path. And we can maybe into here. Can I not convert a string to a path? I have to do this. How do I rust string to path? New from stir. Okay. Path, new. This. And he returns an ampersand path, so I think we're good. So we run now. Segmentation fault. Ooh, that's a new one. I wasn't expecting that. That's nice and exciting. So we actually get to run in GDB now, which is kind of cool. So GDB, we don't have it, so we'll just kind of quickly yoink it from the internet. Okay. Target, debug. Stream, start screen. Run. With our arguments. I guess we'll just pass in any random shit. So we'll pretend that we're starting a stream at like 1440 and the topic is, Okay. Oh, wow, it's so fucked up that I can't even backtrace. That's sick. Very cool, very cool, very cool. So I guess we're just gonna have to bisect. Almost certainly it's this, right? Oopsies. Sorry. Like if I don't try to... Well, let's try not uploading the texture, I guess, and see if that's related. It could be that I thought that the texture doesn't need to be stored in CPU memory. But it's possible that like what happened here is I uploaded the texture, or like I thought I did, but it wasn't actually finished being written. And so the data is like living here, right? And so it's possible that we like free the buffer before the texture is finished being copied to the GPU. And I don't really know how to manage that. OpenGL texture memory free. Let's see if that's like, is that... Assuming you're generating texture, blah, blah, blah. You are wasting memory, blah, blah, blah. Is this guy saying what I'm interested in, though? The output of GLGen textures is blah, blah, blah. He gives you back a handle. This handle stores the state you give it. You overwrite the handle, blah, blah, blah. I guess we'll just try not removing this, like, data. So for now, we'll just return a vec of U8 along with our texture, because that will make sure that it lives. Just to see, right? And then here, we will just keep track of it so it doesn't get freed. And we'll see if we still crash. We do still crash. So that's interesting. So it could actually be in this upload itself, which would be kind of interesting. So can we like print line finished uploading here? And if we see that print, we don't. But we should see that we're about to. About to uploading. Yeah. Okay, so that's good. So that's, I was worried that we would have to keep that buffer around, but we won't. So something in here is wrong. So it would be nice to maybe like print out these parameters. So we can say maybe print line. You might be missing this string literal format. What a funny error message. And he's saying that the end doesn't implement that, so that's fine. We don't need to log the actual data. I don't actually care about that. We can just not convert these when we log them. That's fine. Okay, so we're trying to upload 4096 by 1024. Line size is 4096. Is that right? And color format, bit depth. Yeah, sure. Those are fine. So it would have to be something like bit depth should be unsigned byte. So we have bit depth as 6408. What's this guy? Hex, fuck. Can we print them as hex? Just for me to debug. 1401. So bit depth is 1401, which is right for unsigned byte. And we have 1908 for our color type, which is RGBA. So we have RGBA, unsigned byte, which means that we should have a buffer size that is line size times height. So we should say expected size is line image info line size ties image info dot height, and the buffer is going to be image data.len, right? And so we could say buff size is this, and he doesn't like that this is a multiplication like wrong way, so we can just throw a little as u3 to him. So we have expected size this, buffer size this. So that seems like pretty reasonable. They match up. And then the question is what the fuck is going wrong here? So we bound the texture. Our texture exists. We bind him. We get the line sizes seems right. Our RGBA seems right. Our image data seems right. So who knows? What the hell is that keyboard logger? We wrote it. Let's see if we can find it here. Repositories. This guy. He is here. And if you're curious about technical decisions that were made along the way, there is a YouTube playlist on my VOD channel, linked in the description, that showed the development. That's what it is. Okay, so why the fuck isn't this working? And more importantly, like, a segfault seems crazy to me. Like, a segfault is like a... didn't OpenGL have an error callback that you can get to info event? Might be worth seeing if that's quick to hook up. But, like, I don't think that we would hit that, because, like, this is our call to text image 2D. This is where the error would occur, and instead of erroring, it's just like fucking crashing. So something in here is like, it's just assuming something totally wrong. It would be nice to get like a proper backtrace. I wonder if I do like, I know that there's like a Rust GDB. I wonder if the Rust GDB would work a little better. Rust GDB target debug stream start screen run start time something like 15 o'clock, and topic is ASDF whatever. And yeah, this backtrace is still not fucking working. It's so frustrating. I hate that shit. I hate it. Okay, let's just like, I guess we just have, the only thing that we can do is just double check our inputs. So first let's look at our other calls to text image 2D and see if we're doing something different there. So this all looks pretty the same. It's possible that the color format here is wrong. Like, it'd be interesting to say, let's just try hard coding this stuff. So this is glow inside byte. This is glow RGBA. Oopsies, cargo run. This is certainly still going to crash. Yeah. I wonder if our image is like somehow too big. Like, is there a maximum texture size that we're just like running over? Let's try just maybe like dividing the height by 8 and seeing if we still crash. We're not going to get something sane if we do that, right? But maybe we'll get something reasonable, I guess. Oopsies, this should be Maybe we'll stop crashing, I guess, is what I'm trying to say. Okay, so if I divide my height by 8, okay, so there's two interesting things here. One is we're seeing a brown monkey, which means that there's like, it's somewhat correct. Yeah, and it looks like there's just a good chance that like the max texture size is too small. I'm pretty sure you can query that from OpenGL. Yeah, I'm pretty sure as well. OpenGL max texture size. Let's find out. Widely supported 1024 by 1024, but there's like a way to query it, I'm pretty sure. I've seen it before as well. GL max texture size is defined by the implementation. Okay. Yeah, okay, so let's see. We can say glow max texture size. We can say print line max texture size is this. Max. That's a weird fucking number. Oh, because we're sorry. That's we have to ask probably. The max size of dimensions GL max texture size. There's no way. Am I not supposed to query a parameter to get that back? There's no way that that's actually the max texture size. That's such a fucking odd number. And what's also kind of interesting is like, how do people do 4K textures then? I guess they just map the UV coordinates. They split the texture into 4 chunks or something, and like map the UV coordinates depending on which chunk they're in. We can just dodge this though by just making a 1024 by 1024 texture. That's fine. Resize. Oh, he does say 1024 by 1024. But maybe that's still too big in bytes. So maybe let's just do like 256 by 256 and just kind of see if that does something for us. Okay, so we shrink him by a fuck ton. And then we stop dividing his height by 8. And we run, and we see if we still segfault. Okay, that's interesting. We do still segfault. Even with such a small texture. But it does seem like we are just running over our, like, total size. So is it possible that, like, our color type is somehow wrong? Let's look at the ping documentation. Oh, no, wait, we said that we said our expected size and buff size match. So we should... right, we said expected. Those are definitely like the same size. Maybe it's like that like texture alignment shit. Guessing a parameter is expecting an element number and you're pushing bytes. Oh, that seems possible. But none of these inputs are bytes. Right? We have... Oh, so you think that these need to be divided by 4 for RGBA. That's possible. That definitely seems possible. And then it just becomes hard to test this. So I guess what we should do is we can just like, let's just kind of see if we start like painting over random shit in here, if we can like correlate what we're seeing with what's on the page. So how do we want to do that? Texture, paint, and let's just kind of, I don't know, paint a bunch of him black. How do I draw my alternate color here? Control, Shift, Alt. I don't know. We'll just make it. Right, like let's just do this and see what happens. Save. We're gonna run. So he's still totally brown. What if I make the whole thing black? Now he's brown, but like not that brown. Shouldn't he be not brown at all? There should be 0 brown on him. Am I crazy? It's weird. That's crazy. Did Did I miss a little bit? What if I must be high. Unless I'm like blending in some way that I didn't mean to. What if I make this whole thing like, I don't know, like green? Do I start to see a green image? Okay, so that's working. And is it like only parsing a bottom, like a part of this guy? Oh, so he's probably like interpolating between the blue and the green here, and all faces are being mapped to the same fucking thing. Which makes me kind of think that my UV coordinates are not working correctly. So let's just double check the inputs text image D. So the fact that here we said our pitch, we used pitch and rows before. Pitch comes out of our glyph bitmap. Oh, but he was grayscale. So like the pitch just happened to be equal. If I divide this by 2 instead of 4, we do segfault. So I think you're right that it should be in pixels instead of in bytes. But then it's like, why is this still not working? Oh, I guess maybe our line size and our width are totally different. So maybe we should actually let's try stripping off like when we read it. Oh yeah, that's right. We saw our pitch and our width were totally different, right? Might be a little bit easier to test with cube too. Yeah, that's true as well. We'll see if we need to get into that. Thinking. What was I looking up? I was looking up something. Oh, I was looking up the documentation to this Pung reader, and its output info is the pixel height, pixel width, byte count of each scan line. Aha. So let's just try using width here directly and just see what that looks like. It's odd that like every single UV on the whole guy seems to be exactly the same. You know? So maybe we can look at our UV coordinates in our mesh and see if they're kind of varied. So like 0.93, 0.92, 0.82, 0.63. Yeah, they do seem like varied enough. Like, but it's possible that the image itself is not right. So what we could do is we could construct a mesh that is just a plane and try to render our image to it, and we can get a bit of like a clue as to how our thing is fucked up. Right? Like if we assume that the image is being uploaded correctly, we can say that our mesh is, instead of this, we can just manually construct him temporarily. So vertices is going to be vert and UV. Vert is going to be 0.0, 0.0, 0.0, or maybe I guess it's like negative 0.25 or something. His UV is going to be 0.0, 0.0. I think that that's reasonable. This guy needs to be a vector of these. And this guy needs a little 1.0 at the end. And he needs faces. And my faces are going to be a vector of the first 3 vertices. So 0.032. No, these are indexes, sorry, so that's fine. And the second 3, so 1, 2, 3. These are my faces. Okay, and so now I need to define all these. So I'm going to have 4 vertices. So I'm going to go from the bottom left to the top left to the top right to the bottom right. And my UVs now have to be the same. So this is 1, 1, and 1, 0. Okay. Okay. Oops, and I fucked up my square bracket, so like this. And what doesn't T like? Maybe this? There we go. So now we should see like a plane on here instead of Suzanne. I think I fucked up my vertex order. 0. So we have to draw this out. We have negative 0.25, 0.25, negative 0.25, positive 0.25, positive, 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 negative. So this is 1, 2, 3, 4. Oh, but 0 isn't a valid vertex. Right, I just forgot about that. Okay. That's still not right. Where do we handle... sorry, 1, 2, 3. Oh, and it should be 1, 3, 4. 1, 3, or 0, 2, 3, I guess, if we're 0 indexed. I can't remember if we're supposed to be 0, 1 indexed, but that does look like a plane that is just blue. And so now the question is, why? So what we could do is in our fragment shader, we could actually just try rendering, instead of trying to sample the texture, we could just try rendering the UV coordinate. So we can say vec3 UV 0.0 1.0. This would be vec4. And we can see if the UV coordinates are matching. And that's a good sign that something's just fucked, right? The fact that it's just black is really bad. Yeah, that means that the UV coordinates like aren't getting propagated the way I think that they are. And so there are possible like multiple reasons for this. One is that we could be not setting them correctly. And I actually think now that I'm saying that out loud, I'm pretty sure, yeah, we did not set the index correctly. Fuck. So we had to enable this UV attribute. Hey, there we go. That's much better. Okay. So now if we go back to using Suzanne, or sorry, if we go back to trying to render the texture, so we should be able to go back into our fragment shader, and we should be able to pull our texture, text UV, and we should see our like blue and green. Nice. And now we should be able to stick it on Suzanne. And I think that'll just work. So we'll go back to pulling in our like, go back to however you were when you were reasonable. Nice. Image. Save. And now we go back to loading this guy like this. We're close. We're definitely close. It looks like the UV coordinates are inverted, maybe. So in our 3D fragment shader, let's just try doing 1.0 minus UV just to see if that's a simple flip. That's damned close. Maybe it's like a YX flip. Or maybe it's only flipped in one dimension. So we could say, I guess it would be nice to be able to check how it's fucked up. So let's look at this again. Right, fuck. Like this. And face culling is the issue, I think. I'm pretty sure It's not. It looks like these guys are projected like very nicely onto a static location on there, and they're just on the wrong spot. I think it's more likely that if I were to like look at this guy, that see, I'm seeing it like on the back of his left ear. So let's just draw something over there and look at where that shows up over here, approximately. And we're kind of seeing it like on a little bit of like the front as well, like over here somewhere. So I wouldn't be surprised if there's some sort of X mirroring going on here. So let's just try vec to adjusted UV is equal to UV, and then say adjusted UV.x equals 1.0 minus adjusted UV.x, and say adjusted UV goes in here. And let's see if that looks a little more correct. So now we're seeing kind of like one of the eyeballs is on his back right ear. So let's... Oh, was I drawing the wrong ear before? Back left here. He's got an eyeball here. So that looks like a possible Y flip if we like... Maybe, because we're not really seeing the top of his head very well. So let's flip Y and X, I guess. Hopefully we can gain some intuition here. So what's odd here is it looks like everything's like a little bit offset, right? Am I crazy? Like, here we're seeing like lipstick here, which feels like just a little bit of an X offset. So I guess let's try not flipping X and see if that does it. Aha! There we go. Let's go. Okay, so it was just like strictly a Y flip. That's pretty sick. Let's adjust our camera so that we're in a little bit of a better position to look at her pretty face. So I guess maybe we will rotate a little bit. I guess we want to rotate in like positive direction to look from above, and maybe like only a little bit. And then we want to go, you know, in negative Y by like 0.1 or something. Look at that. Look at that. That's beautiful. That's beautiful. Okay, so what did we do here? We parsed the UV coordinates that came in our object file. We kind of like swizzled them around a little bit so that they were packed nicely with the vertex coordinates. And we like handled duplication of vertex coordinates so that we're getting like unique pairs of vertex and UVs together. That's pretty sick. Pretty sick. The next thing we would want to do is we would want to start looking at like lighting. So what's important for lighting is that the normals of your faces will have like a direction, right? Like here, like this face, like sorry, let's get into it. It's a little better. This face is pointing kind of like up and out, right? And this face is pointing kind of like up here. And what happens is like when you bounce the light off, basically how much light is reflected depends on the angle between like this light here and the normal that is like the angle of your thing. So we're going to need to like load the normals and put a light in the scene and use that to calculate brightness in the fragment shader. And if I understand correctly, you're supposed to like loop over all lights in the scene and like apply that same thing to each light. I don't really know how shadows are cast yet, but we'll figure that out. And I'm kind of like thinking about, the reason I'm like saying all this out loud is because I'm like looking at the clock and being like, well, we're at an hour and a half. And I think that that's going to take me longer than half an hour. And so I kind of want to cap it out at 2 hours here. So yeah, that's pretty fun. I think I'm pretty happy with that progress for today. Yeah, I think I'll call it there. So if you like what you saw, I stream most days around 1 or 2 o'clock Pacific time. Trying to keep like programming varied. So we're doing some 3D, we're doing some operating system stuff. I'm planning on getting into some machine learning stuff soon. I've got like a little bit of an idea for a project there. Yeah, there's a YouTube link in the Twitch description. So if you're watching live and you miss stuff and you want to catch up, there's YouTube there. There's like playlists for all of our different projects. There's a GitHub there. This project is finally uploaded to GitHub. So I uploaded it today and we'll keep it updated as we go. And yeah, if you're watching on YouTube, there's a Twitch link in the YouTube description for if you want to pop by, say hi, chat, whatever. Yeah. Shadows are a lot. Yeah, I'm sure we'll find that out. I can imagine that that's going to suck. Because you kind of have to, you would have to like check any object between you and the light, and I don't really know how you would do that without importing your whole object into the scene. You might be able to do it with some sort of like screen space lighting, but anyways, we'll see. Excited to see where it goes. Yeah, that's all. Thanks. Catch you on the next one. Bye!